Okay guys, this is a quick rehash of what we've talked about the last couple days. So to start with, on Monday what we did was we did a graph that was distance and time, and what we found was there were points on it that led us to conclude that it was a curved, let me do that better, that it was a curved line. So when something was going down an incline, so we had like a incline and the glider was on the incline, and as the object moved down the incline we took distances and we took times, and we found that whenever we did that it formed a curved graph. And then essentially what we did, it's not really important how right now, but we derived the formula d equals 1/2 at squared plus vit using this graph. Alright, then the next day, what we did was we made another graph. Basically what we did was we found the velocities at the end of each of those little paths. We did a velocity versus time graph, and this time we found that it was linear. And we looked at the slope and found that the slope of this was change in velocity over change in time, and that is an acceleration. And so the formula for acceleration is the change in velocity, which is vf minus vi. In other words, the first one minus the second one, and then divided by a time. So you get a is equal to vf minus vi over t. And so these are the two essential formulas for you. So the two basic formulas that you will have are a equals vf minus vi over t, and d is equal to 1/2 at squared plus vit. There are two other formulas. One is the average velocity formula, in case you're asked to find that. That is the total distance over the total time. But that can also be equal to vf plus vi over 2. Probably not going to use this one much, but it might come up. And the second one that we haven't talked about yet, we're going to talk about today, which is 919. We're going to talk about this one. Vf squared equals vi squared plus 2ad. And this is just a combination of these two formulas, and you can use this one. Check on using this one if you don't have time. Like if you don't have time and you're not trying to find time, this one's a good one to use. Okay? Not like don't have time to do the problem, but like don't have the variable time, because it doesn't have time in it. So these are your formulas. This is just a quick little rundown of what we've done the last couple of days. Remember to list out what it is that you're looking for each time. That'll make it a little bit easier for you. And then make sure you read the problems thoroughly.